Unit circle practice part 1. So, in the previous lesson, we built the unit circle, and now I'm going to give you different ways to think about it. This W is called a wrapping function, and it means what are the ordered pairs at t. So, at 45 degrees, what are the ordered pairs? And I'll go up and look a couple times, but after that, I'm going to let you do it, and then I'll just blast through them. I usually make a mistake or two, so always double check. At 45, we see it's root 2 over 2, root 2 over 2. I'll let you handle the rest of those, but now we get to negative 150. Negative 150 is a little bit tricky. What we want to do is go backwards 150 degrees, which is about there. A nice way to do it is to go forwards 150 degrees and then reflect it down. So 150 is this far, and we want to go that far. So that's a nice way to do it. A lot of people find that very useful, but you might have a better way to do it. Whatever works for you. So negative 150 is the same as 210, and that's negative root 3 over 2, negative 1 half. So try the rest of these. I'm going to do them in a second. If you see something greater than 360, you have to wrap it around a couple times and see where that takes you. I'm just going to put the answers up, try and save myself some time, or just do it quickly, I suppose I should say. This is the same as 240. This is the same as 150. I mean this one. I mean this one. It's the same as negative 135. And that's about it. Now we do it with radians. It's significantly more tricky for people the first time. Once you've done it often enough, you realize it's really not that bad. Let's see how I did. We go up to 2 pi over 3 here, which is here. Negative 1 half root 3 over 2. Negative 1 half root 3 over 2. So you can try these on your own. Some of the hard ones are 7 pi over 2. Lots of different ways to do this. I've had people say, well, I'll make that 3.5. So once around is 2, so I want to go 1.5 more. That would get you here, of course. I've had some people say, well, I like doing the pi over 2s where I count 1 pi over 2, 2 pi over 2, 3 pi over 2, 4, 5, 6, 7 pi over 2. Gets you to the same spot. Either way, 0, negative 1. So whichever way works for you, you can freeze the recording and try these on your own. I'm going to fill them in now. Like I said, I make mistakes, so make sure you check my work. And that's about it. Actually, I'll pause it there. You can pause the recording now. Make sure you agree with my work. I'm doing it without a unit circle. I'm just doing it in my head. Hopefully I'm doing it right, but you never know. So, some definitions. You've seen SOHCAHTOA, sine is opposite over hypotenuse. Well, it turns out the opposite is always the x-coordinate, and the hypotenuse is always 1. Pardon me, the opposite is always the y-coordinate, and the hypotenuse is always 1. So we can just say sine is y. Cosine is x, and tangent is defined as sine over cosine, opposite over adjacent, also known as y over x, whatever works. Secant is 1 over x, cosecant is 1 over y, cotangent is 1 over tangent, so it's x over y. You need to memorize these, but it helps if you can actually work them out in your head. And now that we do that, we do this very, very silly trig thing where we say A, S, T, C. What we're saying is that all the functions are positive in here. And we actually, when we do this, we only define the first batch, and by extension, they're reciprocals. So we have to say cosecant, secant, and cotangent are all positive. Here we say sine is positive, and by extension, of course, cosecant. Not going to do that again. Tangent is positive. Down here, cosine is positive. So cosine and secant, tangent and cotangent. All the rest are negative. So we say ASTC. I've seen lots of different mnemonics for that. All students take calculus. There's lots and lots of things. You can do whatever you want with it. So, and as we discussed actually above, when you go there, the x value is equal to cosine, and the y value is equal to sine. If you remember those, it'll save you a lot of time. So, more practice. If sine of pi over 3, we don't want the whole coordinate, we just want the y-coordinate. So, at pi over 3, we get root 3 over 2. And now we got the extra wrappings and the negatives, so they're kind of tricky. You might want to pause the recording and see what you can do, because I'm going to blast through them pretty quick. And here I go. Tangent I have to actually stop and go through. It's y over x, sine over cosine, negative pi over 3. We're at negative root 3 over 2 divided by 1/2. 2's cancel, and we're left with negative root 3. It's one of the trickier ones. Cosecant's 1 over sine. So at pi over 2, sine is 1, so 1 divided by 1 is 1. Cosecant of 240 is sine at 240 degrees, which is the y value. It's 1 over negative root 3 over 2. Flip it, we get 2 over root 3, and rationalize it, negative 2 root 3 over 3. That's tricky, but doable. Secant of 450. It's just secant at 90, which is cosine. Cosine at 90 is 0, so this is undefined. Cotangent at negative 2 pi is x over y back at the origin, and x there is 0, y is 1. I believe I have that backwards. Like I said, I'm doing this without a unit circle. So that will also be undefined. Yep. Secant at 13 pi over 6, that's once around, plus pi over 6 more. Secant is 1 over cosine. Cosine's the x, and that's root 3 over 2 there. I just did this above without the negatives, so I know it's going to be 2 root 3 over 3. Cotangent negative 750 is like negative 30. Cotangent is x over y. At negative 30, x is root 3 over 2. Y is 1/2. 2's cancel. Negative 1/2. And we're left with negative root 3. Which I believe we saw somewhere else. Tangent at negative pi over 3 is the same as cotangent negative 750. That actually makes sense because I've done it often enough. Secant at 1440. It's like saying secant at 0. So cosine at 0 is 1. So this is 1 over cosine of 1. 1. Tangent at 5 pi over 3. Y over x. Negative root 3 over 2 divided by 1/2. 2's cancel. Negative root 3. That makes sense because that's the same as tangent of negative pi over 3, because 5 pi over 3 plus pi over 3 is 6 pi over 3, so I better get the same answer. So you can double check your work as you're flying along here. Cotangent is x over y, which is cosine over sine, at 120. Cosine is 1/2, negative 1/2, and tangent is root 3 over 2. 2's cancel. Negative 1 over root 3, which I know rationalizes to negative root 3 over 3. Tricky. 17 pi over 4 is 4 1/4, so it's like right back in the first quadrant. Root 2 over 2. Cosine of 52 pi is just 1, right back where we started, since it's an even 52 number. This is the same as negative 270, which is the same as 90. So what is sine of 90? 1. So this is 1 over 1 equals 1. Negative 3 pi over 4 is 1. I happen to know that one. Cosecant at negative 7 pi over 4 is the same as cosecant at pi over 4, which is 1 over sine. So now we finally got one of the 1 over root 2 over 2's, which is 2 over root 2, which rationalizes to root 2. Tricky stuff. Cotangent of negative 2 pi over 3 is x over y of negative 1/2 over negative root 3 over 2. 2's cancel. I get 1 over root 3, which is root 3 over 3. Tricky stuff. Sine of negative 15 pi over 4. I feel like I just did that one, but I didn't. It's not quite 4 times around. So that gets me to pi over 4. Same as 17 of pi over 4, so it's root 2 over 2. And cosecant of 300 is the y value of 300, 1 over that. So 300, the y value is negative root 3 over 2. Negative 2 root 3 over 3, we know it rationalizes. And secant at 270 is 1 over cosine at 270, which is 1 over 0, which is undefined. Hopefully not too many mistakes in there, but always double check. If you know how to use a calculator and the radian function, you can definitely double check. Good luck.